ಸರ್ ನೀವಿದ್ದೀರಾ ಇದರಲ್ಲಿ ಸರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬೋದಲ್ವಾ ಅದೇ ಕಾಣಿಸ್ತಾ ಇದೆ ಸರ್ ಇದೆಲ್ಲ ಇಲ್ಲ ಹಾ ಓಕೆ ಸರ್ ಹಾ ಥ್ಯಾಂಕ್ ಯು ಸರ್ ಹಾ ಹಾ Namaste. In the last class, we studied about the topic atoms. Today, we are studying next level of this one, okay? That is nuclear physics. You know about the atoms, okay? Each and every matter in this universe consists of tiny particles called atoms, correct? And what are the things you know about atoms? Last class I told. Tiny particle, correct? So how it looks like? It looks like so, and that is a system is like this. Okay, it consists of a centrally charged, centrally nucleus, and that is the electrons are revolving around the nucleus. Correct or not? So this is the how this is what this we studied in the last. So now what we are studying is now electrons we study. So electrons will revolve around the nucleus because it is mass is less. Okay, so ಏನಾಗುತ್ತೆ nucleus ಮಧ್ಯ central nucleus ಇರುತ್ತೆ. So we study like that only in the in the atoms. Correct or not? So atom is made up of nuclear, that is elementary particles. What are those elementary particles? Electrons, neutrons, and protons. That you know, right? So the central nucleus ಇರುತ್ತಲ್ವಾ, centrally charged nucleus centrally, okay, positively charged nucleus will be there because we know that nucleus consists of centrally protons, and protons are positively charged. Okay, so and whole mass of the nucleus, some mass nucleus mass of the atom is concentrated at the center, that is known as the nucleus. At the center ಏನಿರುತ್ತೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ ಸಹ ಎಲ್ಲದು ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗಿರುತ್ತೆ ಅಂತ ಇದೆ. ನೀವು ಇದರಲ್ಲಿ ಯಾಕಂತಂದ್ರೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಬೇಕು. ಸೊ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದೀನಿ ನಾನು. ಸೊ atom as a whole is neutral. What is the meaning of atom as a whole is neutral? So atom as a whole is neutral means that is inside the center at the positive charged particles, protons are there, and electrons are negatively charged particles, which we all know that one. So number of charged electrons is equal to number of protons, so that so negative charges exactly cancels with the positive charges, so that what happens, we are getting it is atom as a whole is stable. That you know. So now what happens? They consider only protons are there in the nucleus. Before that, So these protons are positively charged particles, and whole mass of the atom as considered at the nucleus. Okay. So here what we are studying is, now we studied about the atoms that consist of nucleus and this. Size of the atoms also last time I told, okay, about what is the size of the atom. It is of the order of 12 to the power of minus 12 meter. 10 to the power of minus 10 to 10 to the power of minus 12 ಅಂತ ಹೇಳ್ಬೋದು, ಯಾಕಂತಂದ್ರೆ depending upon the different nuclei. Okay. Now what happens if you that is a ಇದಾದ್ಮೇಲೆ what is the size of the nucleus? Then size of the nucleus is very very small, of the order of 10 to the power of minus 15. 10 to the power of minus 15. ಇದು ರೇಷಿಯೋ ತಗೊಂಡ್ರೆ ನಿಮ್ಗೆ ಎಷ್ಟು ಬರುತ್ತಪ್ಪ ಅಂತಂದ್ರೆ 10 to the power of minus 10 ಇದೆ ಇದು, ಹೌದಾ? ಇದು 10 to the power of minus 15. Size of the atom to size of the nucleus is approximately like this, okay? ಅಂದ್ರೆ 10,000, 10 to the power of 5 ಬರುತ್ತೆ. Difference is how much? 10 to the power of 5. ಇದನ್ನ ಹೇಗೆ ನಾವು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಬೋದು ಅಂತಂದ್ರೆ, ಸಪೋಸ್ ಟೇಕ್ ಎ ಫುಟ್ಬಾಲ್ ಸ್ಟೇಡಿಯಂ, ಒಂದು ಫುಟ್ಬಾಲ್ ಅಥವಾ ನಿಮ್ ರೂಮ್ ಸ್ಕೂಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ತಗೊಂಡ, ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಒಂದು ಕ್ಲಾಸ್ ರೂಮ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಅ ಹೋಲ್ ಆಟಮ್. ಅಂಡ್ ಒಂದ್ ನಿಪ್ ಇರುತ್ತಲ್ಲ, ನೀವು ಪೆನ್ನಿನ ನಿಪ್ಪು ಸ್ಮಾಲ್ ಇದು ಇಷ್ಟು ಡಾಟ್ ಮಾಡಿದ್ರೆ ಯಾವ್ದಾದ್ರು, ಸೊ ಕ್ಲಾಸ್ ರೂಮ್ ಒಳಗೆ, ದೊಡ್ಡ ಕ್ಲಾಸ್ ರೂಮ್ ಒಳಗಡೆ ಒಂದ್ ಸ್ಮಾಲ್ ಪಿನ್ ಇಟ್ರೆ ಅಥವಾ ಒಂದು ಕಲ್ಲಿಟ್ರೆ ಎಷ್ಟು ದೊಡ್ಡದಿರುತ್ತೋ ಅಷ್ಟು, ಅಂದ್ರೆ ಕ್ಲಾಸ್ ರೂಮ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ದ ಆಟಮ್. ಅಂಡ್ ದಟ್ ಸ್ಮಾಲ್ means stone ಅಥವಾ nib of the pin is considered as a ನ್ಯೂಕ್ಲಿಯಸ್. ಅಂದ್ರೆ ಏನಾಯ್ತು, ಆಟಮ್ ಅಲ್ಲಿ ಹೊರಗಡೆ, ನಾನು ಲಾಸ್ಟ್ ಟೈಮ್ ಹೇಳಿದೀನಿ. ಸೊ ಯಾಕೆ ಆಲ್ಫಾ ರಿದರ್ ಫೋರ್ಸ್ ಆಲ್ಫಾ ರೈಸ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಆಟಮ್ ಇಸ್ ದೇರ್ ನೋ. ಸೊ ಇನ್ ದ ಆಟಮ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಸ್ಪೇಸಸ್ ವಾಯ್ಡ್, ಮೀನ್ಸ್ ಏನು ಇಲ್ಲ ಆಟಮ್ ಅಲ್ಲಿ, ಯಾಕಂದ್ರೆ ಕೆಲವೊಂದು ಆರ್ಬಿಟ್ಸ್ ಅಲ್ಲಿ ಮಾತ್ರ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿವಾಲ್ವ್ ಆಗಿರುತ್ತೆ. ಕರೆಕ್ಟ್ ನಾಟ್, ಇಲ್ಲೆಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರಿವಾಲ್ವ್ ಆಗಿರುತ್ತೆ. ಇದೆಲ್ಲ ಸ್ಪೇಸಸ್ ಇರುತ್ತಲ್ಲ, ಇದೆಲ್ಲ ವಾಯ್ಡ್ ಅಂತ ಹೇಳ್ತಾರೆ, ಏನಿಲ್ಲ, ಖಾಲಿ ಜಾಗ ಇದೆ. ಅರ್ಥ ಆಗ್ತದೆ ನಿಮ್ಗೆ? ಸೊ ದೊಡ್ಡ ಒಂದು ಬಿಲ್ಡಿಂಗ್ ತಗೊಂಡ್ರೆ ಅದನ್ನ ಆಟಮ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡುತ್ತೆ. ಸೊ ಇಟ್ ಸ್ಮಾಲ್, ವೆರಿ ವೆರಿ ಸ್ಮಾಲ್. ಎಸ್, ಆಟಮ್ ಸೈಜ್ ಇಸ್ ಆಲ್ಸೋ ಸ್ಮಾಲ್, ಮಾಸ್ ಇಸ್ ಆಲ್ಸೋ ಸ್ಮಾಲ್, ಎವ್ರಿಥಿಂಗ್ ಇಸ್ ಕರೆಕ್ಟ್ ನಾಟ್. ಬಟ್ ಅಂದ್ರೂ ಸಹ ಆಟಮ್ ಅಂತ ಅಷ್ಟು ಸೈಜ್ ತಗೊಂಡ್ರೆ ಸೆಂಟ್ರಲ್ ಇರುತ್ತೆ, ಸೆಂಟರ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರುತ್ತಲ್ವಾ, ಸೆಂಟರ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ದಟ್ ಈಸ್ ವೆರಿ ವೆರಿ ಸ್ಮಾಲ್. ಆದ್ರೆ ಇಟ್ ಈಸ್ ಡೆನ್ಸ್ಲಿ ಪವರ್, ಮೀನ್ಸ್ ಎಲ್ಲ ಮಾಸ್ ಅಲ್ಲೇ ಬಂದು ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗುತ್ತೆ. ಡೆನ್ಸರ್ is also there because it consists of protons also and neutrons also. Before that, what I told, only they consider as only protons are there in the nucleus. But what is that? Who discovered? James Chadwick. What he told, James Chadwick, he told that, okay, so when the neutral particles exist ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ number of, so mass ನ ಮಾಡಕ್ಕೆ, mass of the atom is, what is the mass of the atom? Atomic mass. What is the atomic number? Atomic number means, I will tell all these things now, okay? Atomic number is number of protons. Now again, with the number of protons is equal to number of electrons, correct? So number of protons is the mass of the atom, Z and the Z and the number of protons is the atomic number. Yes, so hydrogen, helium, these are all the elements, right? Hydrogen, helium, lithium, all the metals are all the elements. Okay. In that, hydrogen consists of one, correct? Not one electron, not a, so one proton, correct? No neutron is there in the hydrogen. Next is what? Next is helium comes, okay? So so proton, hydrogen ನಾನು ಹೇಳ್ತಾ ಹೋಗ್ತೀನಿ, isotopes ಅಂತ ಬರುತ್ತೆ. So isotopes also there, okay? Atomic number is number of protons. Understood? Next is what? Next is about the atomic mass. What is the mass of the atom? Atomic mass. Atomic mass is number of protons and neutrons inside the nucleus. That is known as the, okay, so that is the atomic mass represented as A. Correct? Not so usually double ಇರಬೇಕು, but ಎಲ್ಲ cases double ಇರಲ್ಲ. Lighter elements ಅಲ್ಲಿ lighter nuclei ಅಂತ ಹೇಳ್ತೀವಿ, ಅದ್ರಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೆ, ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ ನಂಬರ್ ಆಫ್ protons is number of protons, ಎಲ್ಲದೂ ಸೇಮ್ ಇರುತ್ತೆ, ಬಟ್ ನಾಟ್ the exact, it's not same as other nuclei. Understood? So these are all things that you have to understand, the atomic mass. ಈಗ ಎಷ್ಟಿರ್ಬೋದಪ್ಪ ಮಾಸ್? ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಹೇಳಿದ್ವಿ, ಸೈಜ್ ಇಸ್ ವೆರಿ ಸ್ಮಾಲ್ ಅಂತ, ಕಣ್ಣಿಗೆ ಕಾಣಿಸಲ್ಲ. ಆಟಮಿಕ್ ಕಣ್ಣಿಗೆ ಕಾಣಿಸಲ್ಲ ಅಂದ್ರೆ ಅದಕ್ಕೂ ಸೆಂಟ್ ನ್ಯೂಕ್ಲಿಯಸ್, ಅದು ಇದು ಕಾಣಿಸಲ್ಲ. ಬಟ್ ವಾಟ್ ವಿ ಆರ್ ಟೆಲಿಂಗ್ ಇಸ್, ವಾಟ್ ಇಸ್ ದ ಸೈಜ್ ಆಫ್, ಎಷ್ಟಿರ್ಬೋದು ಅದ್ರದ್ದು ವೆಯ್ಟ್, ಮಾಸ್ ಎಲ್ಲ ನೋಡ್ಬೋದ. ಸೈಜ್ ಹೇಳಿ ಆಯ್ತು, ಇವಾಗ ಮಾಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ಮಾಸ್ ಆಫ್ ದ ಪ್ರೋಟಾನ್, ಓಕೆ. ಸೊ ನಾವು ಇವಾಗ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿರೋದು ಏನಂತ ಅಂದ್ರೆ, ಇವಾಗ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ವಿ ಆರ್ ಸ್ಟಡಿಂಗ್ ನಾವ್ ಅಬೌಟ್ ದ electrons revolve around the nucleus. Correct or not? Is a very lighter particles. Electrons are very lighter particles of the order of mass of the electron is of the order of 10 to the power of minus 27 kg. What is the meaning of 10 to the power of ಅಷ್ಟು small weight ಇರುತ್ತೆ. 10 to the power of minus 27 kg ಇರುತ್ತೆ. ಯಾವುದು mass of the electron. Very small. Next to mass of the proton is what? Mass of the proton is of the order of 10 to the power of minus 24 kg. ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಓಕೆನಾ ಲೈಟ್ ಇರುತ್ತೆ ಇಲ್ಲಿ ಸೆಂಟ್ರಲ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಇದು ಸೇಮ್ ನ್ಯೂಟ್ರಲ್ ಏನಿದೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಆರ್ ನ್ಯೂಟ್ರಲ್ ಬಟ್ ಇಟ್ ಹ್ಯಾಸ್ ಸಮ್ ಅಂಡರ್ಸ್ಟುಡ್ ಸೊ ಮಾಸ್ ಇಸ್ ದೇರ್ ಬಟ್ it doesn't contain any charge to conservation of this one so in a mass in this one we will use this neutral particle that exists inside the nucleus and this is discovered by whom James Chadwick. He discovered there exists a neutral particle inside the nucleus called neutrons. Okay. Next, what we are studying is we are studying about the mass of the particle. Mass is the mass of the particle. Then AMU gets kg studying in terms of atomic mass unit. What are those things we'll study? Okay. No, so I'm taking the textbook only. From the textbook reference only, I'm using this one. So many things are there. So though the one thing is that, so though the nucleus is very, very but an enormous amount of energy is hidden inside the nucleus, and we have to study the masses. Then it becomes easy to understand the nuclear. So nuclear physics is what? To understand the concept of nucleus. It is not a compact one. Very small means it is very, very compact one, correct? So compact is compact ಅಷ್ಟು ಕಾಂಪ್ಯಾಕ್ಟ್ ಒಳಗೆ ಏನಿರುತ್ತೆ ಪ್ರೋಟಾನ್ಸ್ ಇರುತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ ಸೊ ಬೈಂಡಿಂಗ್ ಅಂಡ್ ಮೆನಿ ಥಿಂಗ್ಸ್ ಇದೆ ಸೊ ವಿ ಆರ್ high amount of energy is also hidden inside the nucleus. That's why it makes an important this concept to understand the nuclear physics. Okay, but what is that we can't see by naked eye so ಅಥವಾ ಬೇರೆ ಯಾವ್ದು ಎಲೆಕ್ಟ್ರಾನ್ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಯಾವ್ದನ್ನು ಸಹ ನಮಗೆ ನ್ಯೂಕ್ಲಿಯಸ್ ನೋಡಕ್ ಆಗಲ್ಲ ನಾನು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದೀನಿ ಇದನ್ನೆಲ್ಲ ಏನ್ ಮಾಡ್ತೀವಿ ನಾವು ಸೊ ಥ್ರೂ ಡಿಫರೆಂಟ್ ಸ್ಪೆಕ್ಟ್ರೋಮೀಟರ್ಸ್ ಮಾಸ್ ಸ್ಪೆಕ್ಟ್ರೋಮೀಟರ್ಸ್ ಅಂಡ್ we are studying the ಇಂಡೈರೆಕ್ಟ್ ವೇನಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋದು ಕಣ್ ನೋಡ್ಬಿಟ್ಟು ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲಿ ನೋಡ್ಬಿಟ್ಟು ಅಥವಾ ಯಾವ್ದ್ರಲ್ಲಿ ನೋಡ್ಬಿಟ್ಟು ಸ್ಟಡಿ ಮಾಡೋದೆಲ್ಲ ಪ್ರಾಪರ್ಟೀಸ್ ನ ಇಂಡೈರೆಕ್ಟ್ ವೇ ಅಂಡರ್ಸ್ಟುಡ್. Now what I am writing is atomic mass and composition of nucleus. So we have to write the mass of the nucleus. Mass of the proton is of the order of what? Mass of the proton is equal to 1.6762 into 10 to the power of minus 27 kg. Okay, this is the mass. Simple mass of the carbon atom is this much. Okay, so we are not using kilogram. Okay, so what in ಹೇಳಿದೀನಿ so size compare ಮಾಡಿದಾಗ ಎಷ್ಟು ಬರುತ್ತೆ next we are using in terms of atomic mass unit. Mass of the electron is how much? Last time I told about this. Mass of the neutron is also same. Okay, mass of the proton is also equal to mass of the neutron, that is equal to 1.6. ಇದು ಪ್ಲಸ್ ಇದು ಮೈನಸ್ 1.6 ಸೇಮ್ ಎರಡೂ ಸೇಮ್ 7 ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಸೇಮ್ ಇಲ್ಲ ರಿಮೆಂಬರ್ ದಟ್ಸ್ ವೈ ವಿ ಆರ್ ನಾಟ್ ಸ್ಟಾಪಿಂಗ್ ಹಿಯರ್ 6 7 ತನಕ ಸ್ಟಾಪ್ ಮಾಡಿಲ್ಲ 2 6 7 ಆದ್ಮೇಲೆ ಮತ್ತೆ 4 9 ಬರ್ತೀವಿ into 10 to the power of minus 27 kg. So and this thought of so how to calculate them next comes. So how to that is how Chadwick discovered. Okay, so nuclei before that I will explain about something about them how we will define about the AMU. So these are all masses, okay, in terms of kg that we are not explaining that one. We'll describe in terms of atomic mass unit. Okay, one atomic mass unit 1U. Okay, 1U is equal to mass of one carbon atom one carbon 12 C12 atom, like this only will do. Okay, so what is the mass of carbon atom? I number it in, so divide by 12. Okay, so that is known as 1 atomic mass unit. We are considering this 9th standard chemistry. How much is the mass of one carbon atom? Mass of one carbon atom is mass of one carbon atom is how much? 1.992647 into 10 to the power of minus 26 kg. Divided by 12. Understood? This is the mass of one carbon atom. Divided by 10. How much is the this one is the how much it is? So 1.66. So this 1.66 is what has an atomic mass in it. Understood? So we'll write in terms of the unit of the atomic mass in it is defined as the 1 by 12, the 1 by 12, the mass of the carbon. Mass of the carbon, C12. Next. So this is mass of the proton is how much? This mass of the proton in terms of what? In terms of, so mass of the proton, okay, mass of the proton is equal to the mass of the hydrogen. That's a very important thing. If you write in terms of this one is in terms of, so it is how much? 1.1.00727. Understood? So 1.00727 atomic mass. Okay. Mass of the single electron. So what is the mass of the single electron? It is in terms of 0.00055. This is a, it is not one in line. Okay, this is what the mass of the electron. So now, what is the meaning of isotopes? We learned already this one. So, but I'm isotopes are the same, okay, same position. What is the meaning of same position? So here all the elements are there in the period table. We have hydrogen, we have carbon, like that, correct? Now, so these almost all the elements isotopes means what? They have the same atomic number but different mass number. Understood? Different mass number, same atomic number. Okay, it has the elements are having the same elements of that is known as health. So carbon idre ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ, ಕಾರ್ಬನ್ 12, 13 ಮತ್ತೆ ಕಾರ್ಬನ್ 14. So ಈ ತರ 3 isotopes ಇದೆ ಅಂದ್ರೆ ಏನಂತ? So 12 is what? 12 is the usually will call it as mass of the carbon. Next is what? 13 is the mass of the carbon and 14 is the isotopes. So different mass. Okay. Having the same but different masses. Now, hydrogen, very light element is the hydrogen. Proton ಏನಲ್ಲ, ಬರೀ ಪ್ರೋಟಾನ್ ಇರುತ್ತೆ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಮತ್ತೆ ಒಂದು ಪ್ರೋಟಾನ್ ನ್ಯೂಕ್ಲಿಯಸ್. ನೆಕ್ಸ್ಟ್ ಇಸ್ ಡ್ಯೂಟೇರಿಯಂ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಒಂದು ಪ್ರೋಟಾನ್ ಮತ್ತೆ ನ್ಯೂಟ್ರಾನ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ ವಿಲ್ ರೈಟ್ ಇಟ್ ದ ಮಾಸ್ ಇಸ್ ಹೌ ಮಚ್? ಡ್ಯೂಟೇರಿಯಂ, okay, heavy water ಅಂತ ಹೇಳ್ತೀವಿ, 82. okay. ನೆಕ್ಸ್ಟ್ ಟ್ರೈಶಿಯಂ ಅಂತ ಇದೆ, ಅದೆಲ್ಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದಾರೆ ಅವರು. ಸೊ ಹಂಗಾಗಿ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಟ್ರೈಶಿಯಂ ಇಸ್ ವಾಟ್? okay. So ಇದು abundantly available. This is abundantly available 99.9%. In 0.1% ಅಲ್ಲಿ ಸೊ ಡಿಟಿನೂ ಇರುತ್ತೆ, ಹೆವಿ ಡಿಟೇರಿಯಂ ಇದನ್ನು ಅಷ್ಟು initially what they thought is, okay, so electrons also because of the radioactive beta decay and next health talk nano. So what they thought is electrons also exist inside the nucleus. Okay, nucleus ಒಳಗೆ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟಿದ್ರು. That is not that is this proved. Okay, prove ಮಾಡಕ್ ಸಾಧ್ಯನೇ ಇಲ್ಲ. Electrons always exist outside the nucleus. Okay, so only protons and neutrons exist inside the nucleus. ಅದನ್ನ ಹೇಳಿ. So next ಏನ್ ಹೇಳ್ಬೇಕಿತ್ತು? Next is about protons, neutrons, and electrons. Right. So I told about the James Chadwick, who discovered the electrons. So he got the Nobel Prize also for, sorry, James Chadwick discovered the neutrons. Okay, James Chadwick. Okay, in the year. Because of what? Because of the masses, because of hydrogen, deuterium and tritium, and the ratio 1:2:3. So, and R must contain in addition to a proton. See, what happens is, okay, masses of hydrogen is 1, mass of deuterium is 2, mass of tritium is 3, like this. But we know that all are contains one proton. Correct? One proton. Hydrogen is one proton. But masses change. Some other mass is also there inside what? Inside the nucleus of the deuterium and tritium. So from that he concluded that there exists some other particle which is not at all a charged one. It is a neutral one. So he named it as neutrons. Okay, James Chadwick ಕಂಡಿದ್ದಾರೆ. Okay, alpha particle experiment. So alpha particle experiment ಮಾಡ್ಬಿಟ್ಟು alpha particles, you know, right? Alpha particles are nothing but helium atom, helium nuclei. ಆಟಮ್ ಅಲ್ಲ, ಹೀಲಿಯಂ ಆಟಮ್ ಅಲ್ಲಿ ಏನಿರುತ್ತೆ, ಆಟಮ್ಗೂ ನ್ಯೂಕ್ಲಿಯಸ್ ಏನ್ ವ್ಯತ್ಯಾಸ ಅಂತ ಹೇಳ್ಬಿಡ್ತೀನಿ ನಾನು, ನಿಮ್ಗೆ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. ನಾವು ಇಷ್ಟು ತನಕ ಸ್ಟಡಿ ಮಾಡಿದ್ದು ಆಟಮ್. ಆಟಮ್ ಮೀನ್ಸ್ ವಾಟ್? ನ್ಯೂಕ್ಲಿಯಸ್ ಇರುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂತ. ನಾವು ವಾಟ್ ವಿ ಆರ್ ಸ್ಟಡಿಂಗ್ ಇಸ್, ಓಕೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಲ್ವೇ ಇಲ್ಲ, orbits electrons only we are studying nucleus only. We are concentrating our all the this one explanation everything on the nucleus itself. Okay, alpha particles are nothing but helium nuclei andre helium alli. So helium particles enirutte, electrons irutte, 2 electrons, correct or not? So what happens if we eject this one? So only nucleus remains, that is known as alpha particle. Alpha particle na beryllium ಅನ್ನುವಂತಹ ಎಲಿಮೆಂಟ್ ಮೇಲೆ ಬಂಬಾರ್ಡ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು, so some other particles also he found out, that is known as, he called it as neutrons. Understood? So and he gave there is mass in terms of he gave the mass as how much? Mass of the neutron as, so he 866. And 1935 he was awarded the Nobel Prize for what? For this one. Okay. So now it is what? How can we write like this? Now it is, suppose if it is a Z is the atomic number. Atomic number at the very, so number of protons. Okay, number of protons. Very important this concept. Okay. Next one is what? A is the mass number. Atomic mass number. It is number of protons plus neutrons. Okay, and the mass number means number of protons plus neutrons. Understood? So next is what? If you want to calculate only n is nothing but neutron number. How will you calculate? So mass number in the, you know, calculate subtract ಮಾಡಿದ್ರೆ A is equal to Z plus N. Correct? So ನಿಮಗೆ ಬರೀ n ಬೇಕಂತಂದ್ರೆ A minus Z like that you can. Okay. So A minus. N is equal to A minus Z. ಯಾಕಂತಂದ್ರೆ so mass of the proton is equal to Z plus N. Next is the how will represent a nuclear species? Very important thing. So how will represent a nuclear species? So we'll represent like this. Suppose any element is there, okay, X, let it be X, okay, we don't know what is that. So it represents C. So in Z ಅಂತಂದ್ರೆ atomic number ಮತ್ತೆ mass ಹಿಂಗೆ ಬರೀತೀವಿ. ಅಂದ್ರೆ ಏನಂತ suppose if you write what is a chlorine ಅಂತ ಬರೀತೀವಿ ಅಂದ್ರೆ so chlorine is how much? ಇಲ್ಲಿ 17 and 35 actually. Chlorine is 34 ಬರ್ಬೇಕಲ್ವಾ 35.5 ಬರ್ತದೆ. ಸೊ ಇತರ ಬರೀತೀನಿ. ಸೊ ಇತರ mass number ಮತ್ತೆ ಇದೆ ಹೀಗೆ ಬರೀತೀವಿ ಯಾವಾಗ. ಓಕೆ ಕೆಳಗಡೆ atomic number okay. So it happens what is it to show that it is this consists of like this. Okay, so suppose it is a whole number that fine. So closing it. So A. So gold we can bring 79 and 197. Okay. So this is a nucleon. So it contains 197 nucleons. 197 nucleons. So let's minus ಮಾಡಬೇಕು. So 17 197 ಅಲ್ಲಿ 79 ಅನ್ನು minus ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? So 79 protons ಅದೇನು? So neutron number you will get. Okay, 79 are protons. Okay, 197 minus 7. ಎಷ್ಟಾಯ್ತು ಅವಾಗ? So after neutron number understood? So protons number ಮತ್ತೆ ಮಾಡಿದ್ರೆ 197. Element of gold is there. Now gold is having 32 isotopes. Oh my. So gold is having 32 means its mass varies from what? 173 to 1 or 20. 173 204. Average value is 197. Okay. So this is the 32 isotopes are there for gold. Very important thing. So next different the next one is isobars. So now next comes I have to define about the thing like isobars. ಇದೆಲ್ಲ ತುಂಬಾನೇ ಬೇಸಿಕ್ಸ್. ಯಾವುದು ನ್ಯೂಕ್ಲಿಯಸ್ ಬಗ್ಗೆ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ಸೇಮ್ ಮಾಸ್ ನಂಬರ್ ಸೇಮ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ಅದು ಐಸೋಟೋಪ್ಸ್. ಓಕೆ ಸೇಮ್ ಅಟಾಮಿಕ್ ನಂಬರ್ ವಿತ್ ಡಿಫರೆಂಟ್ ಮಾಸ್ ನಂಬರ್ ಇಸ್ ಐಸೋಟೋಪ್. ಸೇಮ್ ಸೇಮ್ ಓಕೆ ಮಾಸ್ ನಂಬರ್ different okay atomic number called isobars. Example ಕೊಡ್ತೀನಿ ನೋಡಿ ನಿಮಗೆ isobars ಅಂತ ಹೇಳ್ತೀನಿ. ಸೊ isotones ಅಂತ ಇದೆ. isotones ಅಂದ್ರೆ ಏನು? ಸೇಮ್ ನಂಬರ್ ಆಫ್ protons ಇರುತ್ತೆ ಡಿಫರೆಂಟ್ ನಂಬರ್ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ ಡಿಫರೆಂಟ್ ನಂಬರ್ ಆಫ್ ಮಾಸ್ ನಂಬರ್ ಇದು ಚೇಂಜ್ ಇರುತ್ತೆ ಬಟ್ ಸೇಮ್ ನಂಬರ್ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ ಅಂತ isotones ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ isotones yes. So all nucleides they write on this like this. How will write isobars and isotones. Okay, nucleides with same mass. Nucleides ಮತ್ತೆ ಮತ್ತೆ ಹೇಳ್ತಾ ನಾವು ಬರೀ we are not considering atoms, we are considering only nucleides with same mass number A are called isobars. Understood? Example nucleides of Hc. So it has hydrogen is also having same thing, okay, and He. So this is also having same. So iso same, but different elements. Elements are different. Okay, so nucleides are different, but they are having same atomic number, same mass. Next one is nucleides with same neutron number n, but different atomic number set. So example, so nuclei Hg. So this is mercury. Hg means mercury. Mercury 80 and 198. So listen here. ಎರಡೂ ಸಹ number of protons is equal number of neutrons ಹೋಗ್ತಾ ಹೋಗ್ತಾರೆ higher elements ಅಲ್ಲಿ see 80 plus 8 and 160 ಇರಬೇಕಿತ್ತು. So see number of neutrons is so much high when compared to that one. They are what unstable. So gold is how much? Gold is so 79 is there, 79 is there, and 197, 196, 197. So ಎರಡೂ ಸಹ same. Correct? 98. So this is what this is about this one. So this is having same 187 here. Yes, okay, same nuclear number is same. So this is known as a isotones. Isotones. One marking question. Next comes the size of the nucleus. Very, very important. Okay. Size of the nucleus, it's of the order of 10 to the power of minus 14, 15 ಅಂತ ಹೇಳಿದೀನಿ. Fermi ಅಂತ ಹೇಳ್ತೀವಿ. 1 Fermi ಅಂತ ಹೇಳ್ತೀವಿ. 10 to the power of minus 15 ನ 1 Fermi ಅಂತ ಹೇಳ್ತೀವಿ. Okay. 10 to the power of minus 15 is known as size of the nucleus. Order of ಅಂತ ಹೇಳಿದೀನಿ. ಯಾಕಂದ್ರೆ different ಆಗಿರುತ್ತೆ. Usually it is like this. Okay. 10 to the power of minus 15 is nothing but 1 Fermi. Understood? So now it is Fermi ಅಂತ ಬರಿತೀವಿ. ಈ ತರ ಬರಿತೀವಿ. Okay. Fermi. 1 Fermi. Okay, so how you calculate this? So the class that is their experiment. So Giger and Marsden from there. So Rutherford's on the basis of Rutherford's experiment, Giger and Marsden also concluded that one. That is of the order of what? So it has found that nucleus of mass number has. So size of the nucleus means radius. Correct? Not radius. Radius of the nucleus is given by R is equal to R naught into A to the power of 1 by 3. This is the size of the nucleus. For R naught is known as what? R naught is a constant. Okay. So its value is how much? R naught is equal to 1.2 into 10 to the power minus 15 meter. 1.2 Fermi. R naught value. So A is what? A is the mass number. See, mass number and radius are related to this one. So it is R is directly proportional to cube root of the mass number. So this is also applies this one. So this is directly proportionality ತೆಗೆದ್ರೆ R is equal to so so that is according to Giger and experiment ಮಾಡಿ ಕಂಡುಹಿಡಿದಿರುವಂತದ್ದು. So R is directly the radius means what? Radius of the given nuclei is directly proportional to the cube root of its mass number. So the mass number is the cube root ತಗೊಂಡ್ರೆ ನಿಮಗೆ ಏನು ಬರುತ್ತೆ? So direct proportional ಅದಕ್ಕೆ ಸಂಬಂಧ. Okay, so the radius ಮತ್ತೆ mass number ಸಂಬಂಧ ಇರುತ್ತೆ. So that the density is very large compared to ordinary matter. Same. So density of nucleus is very, very large. Understood? Because of what they understand that we have already, that is because of most of the things inside the atom is empty. Most of the places inside the atom is empty. So all the regions are empty. So that highly dense densities were concentrated at the nucleus itself. So highly dense nucleus are highly dense. Next is very, very important concept, that is that we will discuss in terms of, that is energy mass equivalent reaction. So ನಿಮಗೆ ಈ ವಿಷಯ ಗೊತ್ತಿರಬೇಕು. So ಇದು ಕಂಡುಹಿಡಿದಿದ್ದಾರೆ Einstein. Okay, so what Einstein's found that okay. So Einstein found that each and every matter has some energy in it. Okay. So you can convert which has a mass. Okay. Anything which has a mass can be converted in terms of its energy, just like kinetic energy and all. According to Einstein's theory of relativity, that formula is given by E is equal to mc square. Understood? So mc square is there. What is the meaning of this one? So m is what? M is the mass of any matter, anything. Okay. And c square is what? C square is the, what is C? So usually I told before that only C is the velocity of light. Velocity of light in vacuum. Understood? So E is equal to mc square. So now it is what C is, suppose only is very small particle. So in very small particle E is equal to very small particle. Suppose 1 gram is there. So 1 gram is the weight of the particle. Our guest energy, how much energy is there inside that particle? So m is equal to into c square. C is 1 gram. C is what? 3 into 10 to the power of 8 meter per second. So it is what? Square ಮಾಡ್ಬೇಕಿದೆ. So that 1 gram 10 to the power of minus 3 ಬರೀಬೇಕಾದ್ರೆ kg ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. So 9 into 10 to the power of 16. ಅಂದ್ರೆ ಎಷ್ಟಾಯ್ತು? 10 to the power of 39. 9 into 10 to the power of 13 joules. That is the energy. So like that you can solve. ಓಕೆ. ಸೊ ಈ ತರ ಇದು ಅಷ್ಟೇ ಇಷ್ಟು ಸ್ವಲ್ಪ ಇದನ್ನು ಸಹ ಮಾಸ್ ವಿ ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ಇಟ್ ಟು ಲಾರ್ಜ್ ಎನಾರ್ಮಸ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ. ದಿಸ್ ಇಸ್ ನೋನ್ ಆಸ್ ಎನರ್ಜಿ ಮಾಸ್ ಈಕ್ವಾಲೆನ್ಸ್ ರಿಲೇಷನ್. ಎನರ್ಜಿ ಮಾಸ್ ಈಕ್ವಾಲೆನ್ಸ್ ಎರಡನ್ನು ಸಹ ಈಕ್ವಲ್ ಮಾಡ್ಬಿಡ್ಬೋದು. ಎನರ್ಜಿ ಇಸ್ ಟು ಮಾಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಯಾರು? ಐನ್ಸ್ಟೈನ್ ಹೇಳಿರೋದು. ಓಕೆ. ವೈ? ಬಿಕಾಸ್ ವಿ ಕ್ಯಾನ್ ಕನ್ವರ್ಟ್ ವಿಚ್ ಎವರ್ ಹ್ಯಾವಿಂಗ್ ಮಾಸ್, ಇಷ್ಟೇ ಮಾಡಿದ್ರೆ ಮಾಸ್ ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೇನು so mass of the nucleus is very, very less, but enormous amount of energy is hidden inside the nucleus. Very, very important. And that energy can be utilized in the form of a ಒಳ್ಳೆ ಪರ್ಪಸ್ ಯೂಸ್ ಮಾಡ್ಬೇಕಂತ ಮಾಡಿದ್ವಿ ಆಕ್ಚುಲಿ. ಬಟ್ ಇನಿಷಿಯಲ್ ಏನ್ ಮಾಡಿದ್ರು, ಬಾಂಬ್ಗೋಸ್ಕರ ಯೂಸ್ ಮಾಡ್ಕೊಂಡ್ರು ಅದನ್ನ. ಎಲ್ಲಿ? ಹಿರೋಶಿಮಾ ನಾಗಸಾಕಿಯಲ್ಲಿ ಹಾಕತ್ತಲ್ಲ ಬಾಂಬು, ಲಿಟಲ್ ಬಾಯ್ ಅಂತ. ಆ ಬಾಂಬಲ್ಲಿ ಏನಿತ್ತು, ದಟ್ ಬಾಂಬ್ ಈಸ್ ಬೇಸಿಕಲಿ on the basically this relation only, basically on the basis of energy mass equivalence relation itself. Understood? So these are all the things that we are studying in this classes. Okay. So now it is what next is the nuclear force. So what are the things which is there hidden inside the nucleus? What are the things is there? So much of energy is there. Why so much energy is there? Because so and I will tell you about something about the fundamental forces, because that's also very important here. Okay. So many forces exist in nature. For you all already studied the classical physics. First one is what? Gravitational force. You know what is a gravitational force? So it is important yakantandre competitive exams ಗೆಲ್ಲ ಕೇಳ್ತಾರೆ. So what is mean by gravitational force? If two masses are there like this, okay, and they are separated by a distance some t, okay, then there exists some force, okay, which is directly that is force is directly proportional to product of the masses and inversely proportional to square of the distance between. This is square of the distance between them. This is known as a law of gravitation, correct? Newton's law of gravitation, correct? So this is a constant is that G, that is a gravitational constant. This is that is gravitational force, and the gravitational force is the weakest force in nature. Very, very important. Because of what? Because long range force. Tumba distance ಇರುವಂತ particles ಮೇಲೂ ಸಪ್ಲೈ ಆಗುತ್ತೆ. So between the sun and the earth there exists a force that is known as the gravitational force. ಸನ್ನಿಗೂ ಅರ್ಥಕ್ಕೂ ತುಂಬಾನೇ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ, ಅರ್ಥಿಗೂ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ. ಹಾಗಾಗಿ ಇದು ಲಾಂಗ್ ರೇಂಜ್ ಫೋರ್ಸ್ ಇರೋದ್ರಿಂದ distance ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ it is the weakest force in nature. Which one is? Gravitational force is the weakest force in nature. Next comes the electromagnetic force. Electromagnetic force of attraction or repulsion that exists in between the protons and electrons. Okay. Force, okay, that exists between the two charged particles. So two charged particles, protons ಮತ್ತೆ electrons ಮತ್ತೆ ಇರುತ್ತೆ. So that is the medium force. weaken ಇದು ಅಟ್ರಾಕ್ಷನ್ ಆಗ್ಬೋದು, ರಿಪಲ್ಷನ್ ಆಗ್ಬೋದು. ಆದ್ರೆ ಏನು ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸಸ್ ವೀಕ್ ಇಲ್ಲ, ಯಾಕಂದ್ರೆ ಇಟ್ಸ್ ಆಲ್ಸೋ ಸೇಮ್ ಥಿಂಗ್. ಸೊ ವಾಟ್ ಇಸ್ ದಟ್? Q1, that is Coulomb's force will call it as, okay. F is proportional to Q1 Q2 divided by R square, distance between these two. Understood? That's also there. Next is what? Next is about the, so next concept is about, next comes the next weak nuclear force and the strong nuclear force. Next nuclear force ಬಗ್ಗೆ ಹೇಳ್ತೀನಿ. ಏನದು ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್ ಅಂತ. ಸೊ ಇದೆಲ್ಲದನ್ನ ಆಯ್ತು. ಇವಾಗ ಏನಿದೆ, ನ್ಯೂಕ್ಲಿಯಸ್ ಇಸ್ ಅ ವೆರಿ ಸ್ಮಾಲ್ ಪಾರ್ಟಿಕಲ್, ರೈಟ್? ವೆರಿ ಸ್ಮಾಲ್ ಅಂತ ಹೇಳಿದೆ, ತುಂಬಾನೇ ಚಿಕ್ಕದಿದೆ ಅಂತ. ಅದ್ರೊಳಗಡೆ ಒಂದು ಫೋರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ. ಅಷ್ಟು ಚಿಕ್ಕ ಸೈಜ್ ಅಲ್ಲಿ, ವೆರಿ ಸ್ಮಾಲ್ ಸೈಜ್ ಆಫ್ 10⁻⁻15 ಮೀಟರ್ ಒಳಗೆ ಏನಿರ್ಬೇಕು? ಸೋ ಮೆನಿ ನಂಬರ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ಇರಬೇಕು, ಸೋ ಮೆನಿ ನಂಬರ್ ಆಫ್ ನ್ಯೂಟ್ರಾನ್ಸ್ ಇರಬೇಕು. ಎಲ್ಲದನ್ನು ಸಹ ಏನ್ ಮಾಡ್ಬೇಕು? ವಿ ಶುಡ್ should hold, and that is a different force. That is known as a nuclear force. And nuclear force is a two nuclear forces are there. One is a strong nuclear force and the weak nuclear force. But nuclear force is what? Strongest force in nature. Very, very important this concept. Why it is the strongest force in nature? Because okay, it has a different properties. What are those properties and all? So we'll discuss okay step by step. Okay. So nuclear force ಇಷ್ಟೊತ್ತಂಗ ನಾವೇನ್ step study ಮಾಡಿ ಅಂತ ಹೇಳ್ತೀನಿ. We studied very simple basic topics. That is, we know that okay, atom is made up of this atom made up of tiny particles are as elementary particles. Okay? So many elementary particles are there, but now we study ಮಾಡ್ತಿರೋದೇನು nucleus ಒಳಗೆ ಏನಿರುತ್ತೆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಮತ್ತೆ ಪ್ರೋಟಾನ್ಸ್ ಇರುತ್ತೆ and outmost orbits ಇರುತ್ತೆ electrons will be revolving. These are all charged particles. Protons and nucleus that is protons and electrons are charged particles, and one more particle exists inside the nucleus, that is known as the neutrons. That is a neutral particle. Okay, next is what we study next, size of this one. So size of the atom we already studied is of the order of 10 to the power of minus 12 meter ittu, and iವಾಗ into 10 to the power of minus 10 to the power of minus 10 ittu, 10 to 12 irutte. Okay, it is of the order of 10 to the power of minus 15 irutte size of the nucleus. And then I do there exists that is whole inside the atom. The atom most of the places atom as a whole is empty. Most of the places empty irutte. Centrally concentrated mass. So mass ಇದೆ ಮತ್ತೆ ಏನಿದೆ, so density is more. Okay, that is the concentrated particle inside the central. Okay, outer side, outmost is what? Outmost is electrons will be revolving. ಈ ಪ್ಲೇಸಸ್ ಎಲ್ಲ ಇರ್ತಲ್ಲ, ಈ ಪ್ಲೇಸ್ ಎಲ್ಲ ಏನು ಎಲ್ಲ ಖಾಲಿ 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 ಜಾಗ. ಸೊ ಅದನ್ನ ನಾವು Rutherford experiment ಅಲ್ಲೇ ಕಲ್ತಿದೀವಿ atoms. So this is how it is inside the nucleus. Nothing. Inside the nucleus, inside the atom, most of the places are empty. Inside the nucleus, like this, what? Inside the nucleus, like this, proton and neutron. Okay, first in bari protons ಮಾತ್ರ ಇರುತ್ತೆ ಅಂತ, but James Chadwick ಕಂಡುಹಿಡಿದು neutrons. ಅದರದ್ದು ಮಾಸ್ ಎಲ್ಲ ಹೇಳಿದ್ರೆ in terms of atomic mass little ಹೇಳಿದ್ರೆ. So these are all the concepts we study. And continue next class ಅಲ್ಲಿ ಮಾಡ್ತೀನಿ nuclear force ಮತ್ತೆ binding energy ಮತ್ತೆ nuclear fusion ಎಲ್ಲದನ್ನು ಹೇಳ್ತೀನಿ. So many things are there inside the nucleus. Okay, nucleus ಒಳಗಡೆ though it is so very small, but we have studying many things inside the chapter nucleus. Okay, so next class ಅಲ್ಲಿ ಮತ್ತೆ ಸಿಗೋಣ ಅಂತೆ. ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. Okay.